This is lesson 2.4 on equations of circles. Now we've been discussing this idea of relations and functions. So if you recall, relations is any collection of ordered pairs, and a function is a particular type of relation where essentially we don't repeat any of the first values in those ordered pairs. We talked about an easy way to identify if some given graph is it the graph of a function or not, or a function of y as a function of x. And that easy way was our vertical line test. If we can draw a vertical line through the graph so that it hits the graph more than once, then it is not a function. So we know from that fact that circles are not going to be functions. However, they are still relations. Since it's a circle, we can draw a vertical line that goes through it twice. So it's not a function, but it is still a relation. Now the general equation that describes a circle, we're going to see this in just a moment, it follows directly from the distance formula. And if you recall, our distance formula just followed from our Pythagorean theorem, so we kind of have this interesting connection between circles and triangles, or circles and right triangles. In fact, as you've probably already seen in your pre-calculus class, or will see soon in a college trigonometry class, there really is a deep connection between circles and triangles, right triangles particularly. So if you've studied sine, cosine, tangent, all that fun stuff, you probably know that there's two different ways we can think about those functions, using right triangles or unit circles. This gives us just a little bit more insight into that's not really a random connection. There really is kind of a deep underlying relationship between right triangles and circles. And we're not going to discuss that right now. We don't get into our trigonometric functions in this class. But when you do see them again, just be aware that it's not a random relationship. There really is kind of a deep underlying connection between right triangles and circles. So let's think about this. So we said that a circle is the collection of all points that are equidistant from some other fixed point. So let's call our fixed point h comma k. For whatever reason, this is kind of tradition. Whenever we think about the coordinates of the fixed point, so in other words, the coordinates of the center of the circle, those coordinates are usually, we just call them h comma k. Now, when we have an actual circle, we'll fill these in with numerical values, 3 comma 5 or negative 6 comma 1. But when we're talking about the general formula, we'll usually use h comma k. So h is going to represent the x coordinate of the center, k is the y coordinate of the center. So the point on a circle, which we want to describe, we don't know what it is, so let's just call it an arbitrary point, x comma y. Okay, now the distance between this fixed point and the point on the circle, well, if we think about that, what do we call the distance from the center of a circle to a point on the circle? That's the radius. So the distance here is just going to be our desired radius. So we'll use r for shorthand. Okay, so what we're saying here is we want the distance between some arbitrary point on our circle and the center of the circle to be r. So we're going to use our distance formula. So remember our distance formula? Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to let our arbitrary point on the circle, we're going to let that be 0.2, we're going to let the fixed point be 0.1, and our radius is going to play the role of our distance. Now don't worry about why did we choose this to be 1, this one to be 2. I'm cheating. It honestly wouldn't make a bit of difference which order we chose, but just from what I know what the desired outcome is, that's why I chose the order. You're going to get the same thing regardless of which way you choose it, but again, I just chose it this way because it looks a little nicer. Okay, now I'm going to flip-flop the equation. I'm going to put this on the left-hand side. So I want this square root, it's a nice awkward looking square root sign, x2 minus x1, so in this case x minus h squared plus y2 minus y1, so y minus k squared equals our distance, which is just r in this case. So hopefully this makes sense. We've got the distance between the center of the circle and some arbitrary point on the circle is distance r. So that's what we're saying right here. Well, there's no way that we're going to have a negative value here. So let's just, we don't have to worry about plus or minus or anything. Let's square both sides. Nothing bad is going to happen. There's no negative value that we're secretly sweeping under the rug by squaring both sides. Remember, generally, we square both sides of an equation, we need to check our answers. But here, we're A-OK. When we square both sides, we get this nifty-looking equation here. X minus h squared plus y minus k squared equals r squared. And guess what? That is the equation for a circle. So if we are asked to find the equation of a circle whose center is at h comma k and whose radius is r, this is what we'd say. And we'd leave it exactly in this form. We don't want to multiply that out. We don't want to square out those binomials. That's just going to be a big mess. We're actually going to work on cleaning up that mess in the next section. So this hopefully seems pretty easy, but just fair warning, next section is significantly more difficult. Going in this direction is much easier than going in the opposite direction. Given a squared out equation of a circle, how do we get back to the information of where is its center, where is its radius? So we'll take it easy today, but be prepared tomorrow. It's going to be a little bit more tedious, a little bit more involved. But we'll do an example of this real quick just to make sure that we have a good, solid understanding of what we're saying here. So here's a quick, simple example. Find the equation of the circle with center 3, -1 and radius 2. So if we remember our general form, it's x minus h squared plus y minus k squared, that's a 2, equals r squared. Now, in the context of a drill problem, you're honestly just going to have this memorized. So if you're running out of room in your brain, just get rid of something. You don't really need to know all those dates for history probably. But you really do need to know this for the purposes of our drills. Now later on, if you have a little bit of time and you completely blank on what the equation of a circle is, remember this is just a different form of our distance formula. So if you have one or the other memorized, you've got them both. So x minus h squared plus y minus k squared equals r squared. We just need to remember this, remember what is what. So h is going to be the x-coordinate of our center, k is going to be the y-coordinate of the center, and r, that's the easiest to remember, is just the radius. At this point, just plug it in. So x minus h, so x minus 3 squared, oh, that's terrible. There we go. X minus 3 squared plus y minus k, so k is -1, so y minus -1 becomes plus 1 squared equals r squared. So 2 squared is 4. There we go. It's really that simple. The hardest part is having this memorized. If you have this memorized though, these are easy peasy, no problem whatsoever. The only place you might mess up is doing something silly like saying y minus -1 is still y minus 1. So don't do silly things like that. But the trickiest part is going to be just having this memorized. For the purposes of our drills, you'll have a fair amount of time, I suppose, if you completely blank out. But this is meant to be one that you can just instantly write down. Don't really have to think about it. Just remember, here's the general formula. Here's what the specific answer is in this case. Box it in, move on to the next one. So these are meant to be pretty simple. But once again, what we're doing next time is we're looking at what do these things look at if we do square these out, if we do group everything together. They're not as pretty looking, and getting it back into this nice form takes a fair amount of work. It's not impossible. I don't want to scare you too much, but it's not nearly as easy as this is, unfortunately. So be looking forward to that fun, but for now, make sure that we have these down pretty well.